Welcome guys, 3.7. I'm live from the Smith Cave. So you can see the world's behind me over there. And that is an arcade cabinet, and you're going to hear my dog randomly walk behind me. But let's get started. 3.7, equations of lines in the coordinate plane. Yes, we are talking about equations, so we're going back to basically Algebra 1. This is going to be legit. So our goal today is to graph and write linear expressions. Just kidding, equations. Alright, let's get to our stuff. By the way, I'm super pale. I haven't been in the sun in years. Alright, first up, write everything here. Key concept, definition, symbols, and diagram. Write it all. What are we talking about? We're talking about the slope. Okay, slope is, in layman's terms, rise over run. You hear it later on in higher level math as the rate of change. It's as one thing increases over time or increases over another variable. And we find the slope using slope formula, which we've already discussed this year. So you'll be looking again at slope, x to y minus y1, or y1 minus y2 is how we can find slope. Actually, we haven't talked about slope yet. I apologize. We talked about midpoint. And x1 minus x2, and this is how we can find the slope. Basically, how quickly something rises or falls on our coordinate plane. Alright, boom. Let's go to the next one. You wrote all that down, right? Good. Okay, I'm going to squeeze my face right over here to the side. And we're going to graph using two different forms. I am 100% sure that you guys should be familiar with the first one, slope-intercept form. We use it heavily in Algebra 1. And then we have point-slope form, which some teachers go into at length, some teachers don't. We're going to be talking about it a lot in here. So we got to know both. Basically, slope-intercept form is made up of a slope and an intercept, hence the name slope-intercept form. They're like geniuses in how they come up with this stuff. They're ridiculous. The second form is called point-slope, and it's made up of a point and a slope. Again, I don't know how they come up with this stuff. Genius, genius. Please write both of these down. Let's get some practice with both. Booyah. Okay, first example. Make sure you write the problem, and you don't have to write all three graphs. We're just going to look at the correct one, okay? So first of all, what form is this in? This is in slope because we have the slope, and it's in intercept because we have the intercept, okay? So make sure that you guys go ahead and write down everything right now. I'll be checking. Here's our slope. There's the slope right there, and our y-intercept right here. When I think about slope, I like to go ahead and discuss it in terms of rise over run. So we have 3 over 1. So I'm going to go up 3 units and then over 1. Up 3 units over 1. And the intercept is just where it's going to hit the y-axis. This is a y-intercept. So let's go ahead and make sure which one's which. So -4, I'm going to actually look there first. So that is -4. Boom. So that could be a potential. This is a +4, so that's not going to work. Down here, -4. That looks good. That looks good. Over here, that's a +4. No bueno. Okay, so we've eliminated 2 of our options just by looking at the y-intercept. So, what if I wear my hat like this? I'm going to do it. Why not? Keeps the sun off my face. So the y-intercept here is 3 over 1. Okay, so from this point, I should go up 1, 2, 3, and run 1. And I do. So that doubly looks good. Over here, if I went up 1, 2, 3 over 1, I missed it. That went up 1 over 2, so that's not correct. So this is our correct graph. So go ahead and draw this graph correctly, indicating that it has -4 as our y-intercept, and it has a slope, just like we wanted, of 3 over 1. Okay, slope of 3 over 1. We always rise and on the top and run on the bottom. Okay, it's kind of hurting my head, so I'm just going to kind of normalize that out. Alright, let's move on to problem number 2. Okay, we're going to do this one so fast, it's unbelievable, but this is problem number 2. And write an equation with the slope-intercept. We know slope-intercept form, so all we really have to do is, well, y equals mx plus b. We just plug it in. Instead of m, we're going to put in our slope, which is 3. And instead of b, we put in our y-intercept. And that's it. We're done. That easy. We can graph that like that. Okay? You just saw my wife walk past. Did you see her? She's a doll. Alright, moving on. Problem number 2. That was so easy. Okay, this one's a little bit harder, but still not that bad. We have a point, I'll call it x1, y1, and we have a slope. I wonder what form we're going to put this in. Point slope, you're right. Okay, so y minus y1 equals, what was that again? I know, slope and x minus x1. So this is point slope form, another form that we need to know. I'll probably give it to you on the test, but we should kind of know it. And all we do is we plug in a point, we plug in a slope, and we're done. Here's the trick. There's a negative built into the equation, so when you write it, you got to be careful about that. Y minus 5. So the 5 looks negative, but he's really chilling. Next, m, which is 2. And then x minus a negative 1. So we should just turn that into a positive sign. And there we go. We wrote the equation. See? So easy. Alright, next. Okay. That's my wife. My baby's probably going to cry. So he's upset that he doesn't know how to do the math yet. But he'll learn. Anyways, here we go. What is the equation for the line at the right? I believe this would be this line here. Oh, listen to that. It's beautiful. Here we go. And we have 2 points. So what we want to do is I'm going to actually label these 2 points while we listen to the sounds of nature. Okay, I'm going to actually label these 2 points, x1, y1, and x2, y2. And we don't actually have a point-point formula. So again, we're trying to write an equation. We don't have a point-point formula, but we have a point slope, and we have a y-intercept slope, or slope-intercept form. I don't know what the y-intercept is. It kind of looks like it's hidden in the middle, so I can't use slope-intercept form. But I can use point-slope form, because if I have 2 points, I can find what the slope is. So let's go ahead and find the slope. And our slope formula, conveniently, is y2 minus y1 over x2 minus x1. And if I have a point and if I have a slope, I have a formula. So let's go ahead and plug that in. y2 is 5 minus a negative 1. So I've got to be very careful. There's a negative in the equation. x2 is 3 minus a negative 2. So this is going to add, and we're going to get 6 over 5. And that's our slope. So we have a slope. Now that we have a slope, we can use point slope. Now it doesn't matter which point we use. We can use either one we want. So we're going to go ahead and switch colors of violet. I do not think I ever used violet. So we write the equation. And I can pick any point. I'm just going to pick this one here because I already labeled it x1, y1, but it doesn't really matter. Y minus a negative 1, that's going to become a positive 1, equals, there's my slope, we found it already, and x minus a negative 2, that's going to become a positive 2. And there we go. Just like that. Okay. Uno más, one more problemo. Okay? Okay, here we go. Alright, here's our last problem, and what we have here is a horizontal and vertical line. How do I write equations for horizontal and vertical lines? Okay, here's the deal. Let's go ahead and write this out. So horizontal, I'm going to write this under here. It's going to be awesome. And vertical, I'm going to write this under here. Okay, horizontal goes like that. Look how white my arm is. That's impressive. Vertical goes up and down. Okay? So, how am I going to do this? So let's just say BB-8, he's rolling along, and he doesn't know what he's going to do. It had nothing to do with anything. I just wanted to show you that I had BB-8. Okay. Horizontal lines. Which is the horizontal line? Let's go ahead and highlight. Boom, boom, yellow, yellow. Okay? So, and can I write in yellow? No, it's going to look horrible. Let's write in black. What line, what axis does the horizontal line hit? It hits Y. So it's going to be a Y equals line. Where does it hit it? At 4. Done. Did you see that? I asked myself, where does the horizontal line hit one of my axes? Which one does it hit? Y. Where? 4. The only thing that's true about the horizontal line is every point on this line has a Y value of 4. That's why we just say Y equals 4. Now, this is going to get crazy, guys. You probably won't believe me, but sky blue, here we go. Whoop. There's a vertical line going up and down. And where does it hit? Well, it hits the x-axis, so it's going to be an x equals. And where does it hit? It hits at 2. So x equals 2. What is true about every point on here? Well, the y's are changing, but the one thing that's staying the same is x is always going to equal 2. There you go. Horizontal, y equals. Vertical, x equals. I never remember which one's which. I just look at which axis does it hit. I mean, where does it hit? And that creates the problem. Okay? Alright. I feel like I'm in the movie, like Hook, like, Shmee. I don't know if you've ever seen that movie. Alright, guys. Toodles. It's also a reference to the same movie.